Welcome to our Science and Technology PBL website. Our project focuses on material world through adapting one of the top 10 ocean polluters to be more sustainable in order to save our oceans. So this page just begins with a welcome to the scientists of Year 4 and gives them a brief introduction of the task. This is followed by the purpose and the content that we have embedded within the site. Further down, we have what information they can find, such as instructions on each task, scaffolding, worksheets, links to particular online tools, and much more. Then the final question we have here is, how will the activities develop my understanding of the chosen task, which just provides students with a brief outline of what each activity is. So here on the page titled, What is the problem?, the students are introduced to the driving question as well as the problem statement for the task. So our driving question is, how can we redesign one of the top 10 ocean polluters to be more sustainable? And as we scroll down here, we've got a little image. This one just has the driving question at the top and briefly outlines what the activities are. So for activity 1, they're researching it and expanding their understanding on pollution. In activity 2, they're redesigning one of the top 10 polluters. In activity 3, they produce their sustainable product using Tinkercad. And in the assessment task, they present this to the class and justify and reflect on their final product. Then as we scroll down, we have our problem statement, which we have made a little video ourselves as a little news report speaking about the problems with our ocean and what we need our scientists to do.
This is our assessment/outcomes page where we have outlined the stage, subject, skill and strand. Further down, we have also added the 2 thinking skills which we believe students use throughout the assessment, as well as links to learning across the curriculum. Most importantly, we have added multiple content points from both design and production and material world alongside the 2 outcomes. We have listed next to each outcome and content point which activity or assessment task they link to in order to ensure students are fully engaging with the syllabus and learning the content that NESA requires them to learn. And finally, we have detailed use and purpose of all the technologies used in the activities and assessments and why they're important, alongside the final submission instructions.
All right, so here we have our development page. First of all, we have our role delegation here. So we've broken up the tasks as per the teaching and learning cycle. So activity 1, created by Laura, is really all about building the field and exploring the topic, and that's done under modelled construction. Tom's activity 2 is all about joint construction to find the solution, preparing to make through sketching, researching and designing their plastic waste alternative product. Or as we've titled it for this, this research project, the plastic pollution solution. And for Maddie's section, it's independent construction. So the students are creating the solution to their problem, they're presenting, and that also comes under the assessment.
This is our activity 1, which forms the base of the whole assessment. Students are to just investigate and research the problem as a whole. We have listed a bunch of broad questions here, which they can interpret as they like. We have decided to do activity 1 and the whole assessment in pairs. On the side here, we have 2 really helpful videos in which students can use. And step 2 of activity 1 is presenting their research in a fun way, including an animated video or PowerPoint.
So here we have activity 2, plastic pollution and you. Now, students are going to work in pairs to review this graph, the top 10 most problematic polluter, and they're going to pick one to redesign using more sustainable or recycled materials. They're going to create an annotated sketch of this item using the following template. And you can just click here, all links are live, and it reminds them to annotate their design with intended materials and design features. Now they can also use this digital version, a Sketchpad, if they're more computer inclined. Now, to help their learning, we've given them some videos to give them some ideas. This one's on materials, this one's on the environment, and this one's on marine life and how plastic affects it.
All right, so this is activity 3, which is to create your plastic pollution solution. It follows activity 2, whereby students now progress through the design process and create their design. So the students will use Tinkercad to create their designs, and we'll have a little introduction here, and then it's just an opportunity for the students to review their knowledge on Tinkercad and have an overview of the task. Following this, we have 3 tutorial videos to assist the making process. The students are then guided to screenshot and paste their designs in the Google Slides document, which is really just for assessment purposes. And then we have a hyperlink to the slideshow for them there. To support the students and limit opening of tabs, the Tinkercad website is embedded here. It's really just for ease of access and time efficiency. Students will then have their work reviewed and marked by the teacher before they 3D print. It's just to ensure that everything runs smoothly throughout the 3D printing process. And task, step 1, ask students to follow on from the activity 3 to create a screencast using Screencastify. Just to explain their design. So students are to speak against the success criteria that we have set here. So they just have 5 points here that they have to tick off. The Screencastify tool is embedded within the website so that the students stick to the website, aiding the effectiveness of their time management. And then we have step 2. So the step 2 of the assessment asks the students to add their link to their screencast to the slideshow that's hyperlinked here, followed by the coming together as a class to present. Now, when the students are not presenting, in order for them to remain engaged and reflect on their peers' work, they are to comment on the corresponding slide of the group that is presenting. So they're to comment with one thing that they loved about the design and one thing that they wish that the design had. So it's really just keeping a specific emphasis on the positive and constructive language when providing feedback within the classroom. So here we have the student example of assessment that the students had to complete. So first of all, the students had to create a screencast using Screencastify. So we have here the presentation of their design, their slideshow. Beneath, the screencast that they created is here. So students would have posted this into the slideshow. Following this, we have the student feedback that each student would have done for the presenting groups. That the students had to respond with one thing that they loved about the design and one thing that they wish that they had. So we have the student examples just here.
So here we have the marking rubric. It's a criteria-based assessment rubric with 4 sections corresponding to each activity: 1, 2, 3, and the 4th final activity. Each worth is 25%, and in each section you can get 5 different marks depending on your level of achievement. A, excellent, gets you 5 marks, down to an E, a fail of 1 mark. And you'll see the examples here of an A is an annotated sketch highly successful at identifying and describing how the properties of different materials suit their design purpose. And if it's not successful, it's a fail. If it's somewhat, there's a C. So yeah, you get a range. Very effectively planned and designed. A, not planned and designed with any support from any explanations. That's a fail. So we clearly differentiate the level of achievement.